All right, we got a 10-month-old infant presenting with vomiting, lethargy, and poor feeding. We got metabolic acidosis, hypoglycemia, and methylmalonic acid in the urine. So what's going to be the cause of this? So whenever we do biochem questions, I like to break them down so it's super simple. Basically what's happening here is we got some protein, we got some fat. When fat turns into propanyl-CoA, then methylmalonyl-CoA, and then succinyl-CoA. Succinyl-CoA plugged into the TCA. That's the mechanism. Okay, so if we have vitamin B12 deficiencies, then the enzyme that's called Methylmalonyl-CoA Mutase can't finish the job. You can't make succinyl-CoA. All right, so I'm just gonna go ahead and paste this little line of logic here. Boom, okay? So we can't make this little last step. We can't finish the job, and so we're gonna have methylmalonic acid build up in our body. And so the kid has too much methylmalonic acid here, causing them to pee. So the vitamin that they're missing is this B12 because they don't have the mutase to make this happen. Okay, kind of a memorized question here, but let's look at the other ones. Like vitamin C, for instance, would help with collagen wound healing. Vitamin D helps with calcium. Vitamin A would be like vision and stuff. And so just knowing the pathways of how you get from protein into the TCA cycle is going to be key for this question. And there's not too much to go over outside of this in this question. Just know that your body breaks down amino acids and fats into propanyl-CoA, and then that goes to methylmalonyl-CoA, and then it goes on in this little pathway. The other answer choices, like PKU, that's a phenylalanine hydroxylase deficiency right here. That leads up to a buildup of phenylalanine, not methanol acid. And that would have your like musty odor and intellectual disability if it's untreated. That's our correct answer is B. Ornithine, so that's going to be causing your ammonia buildup, causes your hyperammonemia. And it doesn't involve your methylmalonyl-CoA at all. So you might have symptoms of like lethargy and vomiting or like a coma from the ammonia, but you would not have that acid buildup. And so you wouldn't see that acid in the urine. Okay, pyruvate dehydrogenase. That one blocks conversion. So you might think pyruvate dehydrogenase because that's, you might say that's involved in several different pathways. Like, let me just click this here. Blocks conversion of what to what? Pyruvate to acetyl-CoA. And that'll lead to lactic acidosis. And that's not going to be related to propanyl-CoA at all, or methylmalonic acid at all. Maple syrup, that's going to be your branch chain amino acids like your valine, isoleucine, and leucine. And that's going to be your sweet smelling urine, definitely not going to be this acid stuff. So there we go. Only B12 deficiency causes the backup of methylmalonyl-CoA mutase, which leads to the increase of the acid. So you can't use that TCA cycle and get the energy. So that's all there is to it. Hopefully this is helpful. If it was, like and subscribe.